Hello everyone. The content of our lesson today is the sulfur content in crude oil. The sulfur content in the world's crude oil is continuously increasing. Currently, crude oil with a sulfur content above 1% accounts for more than 55% of the world's total crude oil production. It is predicted that the average relative density of crude oil will rise to 0.8633 g per cubic centimeter, and the sulfur content will increase to 1.6%. Sulfur content refers to the mass percentage of sulfur measured in the tested fuel oil. Let's take a look at the classification of sour crude oil. The main components of crude oil are carbon and hydrogen, accounting for 83% to 87% and 11% to 14% respectively. There are also small amounts of elements such as sulfur, oxygen, and nitrogen. When sulfur reacts with air, it produces sulfur dioxide and sulfur trioxide, which then interact with water to form sulfurous acid and sulfuric acid, causing air pollution and harming the environment and human health. In 2001, the China Petrochemical Corporation issued the Safety Management Regulations for processing high-sulfur crude oil, defining crude oil with a sulfur content above 1% as high-sulfur crude oil. With the continuous expansion of coastal refineries in China processing sour crude oil and the increasing environmental protection requirements in China, the problems faced by processing sour crude oil are also increasing. Sour crude oil has two prominent characteristics. First, high sulfur content. For example, the sulfur content of Iranian lavin crude oil is as high as 1.938%, and the sulfur content of its vacuum residue above 500 degrees Celsius is as high as 4.304%. Second, high light distillates and high gas oil yield. For example, the mass yield of high light below 180 degrees Celsius in Saudi berry crude oil reaches 22.39%, while in China's Xinli crude oil, the mass yield of light distillate below 180 degrees Celsius is only 4.18%. Therefore, processing sour crude oil brings about issues such as modifications in processing technology, equipment corrosion and protection, and environmental protection issues. Except for Xinli, Jianghan, and Gudao crude oils, China's petroleum are mostly low-sulfur crude oils. Sour crude oils mainly come from the Middle East, such as Saudi Arabia, Iran, and Iraq. Compared with China's Xinli crude oil, these sour crude oils have more light distillates, and their density, viscosity, acid value, gum content, pour point, and flash point are all lower. We often say that clear waters and green mountains are as valuable as mountains of gold and silver. Through the study of sulfur content, students should build a strong awareness of environmental protection, aspire to work in the environmental protection cause, become practitioners in environmental protection, and contribute to society relying on their professional knowledge. 2. The state of sulfur in crude oil. Sulfur in crude oil includes elemental sulfur, hydrogen sulfide, mercaptans, sulfides, disulfides, thiophenic compounds, and sulfur-containing compounds with large molecular weights and complex structures. We can classify the sulfur present in crude oil into active sulfur and non-active sulfur. Elemental sulfur, hydrogen sulfide, and low molecular weight mercaptans, which can directly react with metals and cause equipment corrosion, are collectively referred to as active sulfur. Sulfides, disulfides, and sulfine, which cannot directly react with metals, are collectively referred to as non-active sulfur. Generally speaking, when the temperature is above 200 degrees Celsius, active sulfur is more likely to cause corrosion. When the temperature is below 200 degrees Celsius, corrosive sulfur generally only accounts for 20% to 40% of the active sulfur. Sulfur compounds in crude oil are mainly distributed in the heavy fractions. The sulfur content in gas oil and residue accounts for more than 80% of the total sulfur. These sulfur fractions entering secondary processing units pose a threat to the equipment. Research shows that mercaptans and hydrogen sulfide are mainly distributed in fractions with boiling points between 50 to 250 degrees Celsius. Elemental sulfur and disulfides are mainly distributed in fractions with boiling points between 100 to 250 degrees Celsius. That is, the active sulfur in crude oil is mainly distributed in light distillates boiling points below 250 degrees Celsius. Sulfides and thiophenic sulfur compounds are mainly distributed in fractions with boiling points above 200 degrees Celsius. Thiophenic compounds usually account for 50% to 70% of the total sulfur. The higher the boiling point of the crude oil fraction, the higher the proportion of this type of non-active sulfur. Moreover, non-active sulfur compounds are generally more difficult to remove than active sulfur compounds, which is a major issue in processing sour crude oil. 3. High-temperature sulfur corrosion and protection. During the processing of sour crude oil, as non-active sulfur continuously converts to active sulfur, sulfur corrosion exists not only in primary processing units, but also in secondary processing units, and even extends to downstream chemical units. It can be said that sulfur corrosion runs through the entire refining process. High-temperature sulfide corrosion environments refer to corrosive environments formed by sulfur, hydrogen sulfide, and mercaptans in heavy sections above 240 degrees Celsius. Typical locations include the lower part and bottom pipelines of the atmospheric and vacuum distillation columns, atmospheric residue and vacuum residue heat exchangers, catalytic cracking and delayed coking units, the lower part of the main fractionator, etc. The rate of high-temperature sulfur corrosion depends on the amount of active sulfur in the crude oil, but it is also related to the total sulfur content. As the temperature increases, sulfur corrosion gradually intensifies, reaching its peak at 430 degrees Celsius, after which corrosion begins to decrease. Therefore, for high-temperature sections of refinery tower shells, carbon steel clad with ferritic stainless steel composite plates can be selected. For tower internals, options like carbon steel aluminized can be used. Carbon steel aluminizing can effectively inhibit high-temperature sulfur corrosion. Many refineries in Japan use this material, with a service life of over 6 years. When processing crude oil containing acid and sulfur, adding high-temperature resistant corrosion inhibitors can effectively prevent naphthenic acid corrosion. Besides selecting reasonable processing flow schemes, controlling corrosion in processing sour crude oil mainly involves strengthening process anti-corrosion measures. Taking 1 desalination and 3 injections as an example, the deep desalination target of some foreign refineries reaches 1 mg per liter, while domestic refineries often still fail to meet 3 mg per liter. This is also one of the directions for our refining and chemical practitioners to strive for. Alright, that concludes this lesson. Goodbye. See you in the next class.